Look carefully. What you see begins as noise, just chaos, random numbers. But slowly, a pattern emerges. To you, this is clearly the digit 5. To a neural network, though, it sees nothing but numbers, 196 of them. So, how do we turn numbers into understanding? We start with the simplest unit of thought, the neuron. Every input arrives carrying a value, and every connection carries a weight, a dial that says, pay more attention to this one, less to that one. The neuron does something elegantly simple. It multiplies, it adds, then it squishes the result into a decision. Multiply, add, squish. Remember that. It's the heartbeat of every network ever built. One neuron alone is powerless, but stack them, wire them together, let the output of one become the input of the next. And now you have a network. And depth is where abstraction begins. Here's the beautiful part. Each layer learns something different. The first layers learn edges, simple boundaries where light meets dark. The middle layers combine those edges into shapes, curves, corners, loops, and the deepest layers, they see the whole object, a face, a digit, a cat. But how does a layer actually find an edge? With a filter, a tiny 3 by 3 window that slides across the image, multiplying and summing at every position. Where the image changes sharply, the filter lights up. This is convolution. This is how a machine learns to see. Now, a humbling thought, a small network has maybe 10 weights, a useful one has millions, and GPT-3 has 175 billion of them, every single one learned from data, which raises the obvious question, how? The network makes a guess. Information flows forward layer by layer, and it's wrong almost always at first, very wrong. We measure the error, and then this is the idea that launched modern AI, we send that error backwards. Every weight learns how much it contributed to the mistake, and each one nudges itself, just slightly, in a better direction. Do that millions of times, and the network learns. Step back for a moment. Every layer is really doing just one thing to the data, applying a transformation to space itself, stretching it, shearing it, rotating it, until what looked tangled in one space becomes separable in another. That's the whole game, bending space until the answer becomes obvious. One last piece, the curves, sigmoid and real U, are the squish I mentioned at the start. Without them, stacking 100 layers would be mathematically identical to stacking just one. They introduce nonlinearity, the crack through which true learning enters. Numbers in, numbers transformed, numbers out. That is a neural network. Now you know how it sees